When learners first hear that Linux can authenticate against a directory, the phrase directory-backed authentication can sound like one magical thing that either works or does not. In reality, that phrase describes a set of cooperating technologies that solve different parts of the identity and access problem. Some technologies focus on storing and retrieving identity information, like users and groups, while others focus on proving identity securely without sending passwords around. And still others focus on interoperability with Windows-style environments and file-sharing expectations. Because these technologies are often used together, beginners can struggle to tell which one is responsible for which job, and that confusion makes exam scenarios feel unfair. This episode builds a clear map of 3 names you will see constantly in directory conversations: Lightweight Directory Access Protocol, LDAP, Kerberos, Kerberos, and Samba. The goal is to understand what each one is for in exam language, how they fit together, and how they fail differently. Once you can separate identity data from authentication proof and from compatibility tooling, directory-backed auth stops feeling like a single black box and starts feeling like layered plumbing you can reason about. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A strong starting point is to return to the 2 questions we separated earlier. Who are you and what are you allowed to do? And then add a third question that is just as important in shared environments. How can you prove it safely? A directory system needs a way to store identity facts, like usernames, group memberships, and attributes about accounts. It also needs a way to authenticate users, meaning to verify that the person attempting to log in is truly that user. Finally, the system needs a way to apply authorization locally, meaning to translate group membership and policy into real permissions on the Linux machine. LDAP is most closely tied to storing and retrieving identity facts. Kerberos is most closely tied to secure authentication through tickets rather than repeated password exchange. Samba is most closely tied to interoperability, meaning it helps Linux participate in Windows-style domains and services, including file and printer sharing and certain identity integration patterns. The reason the exam highlights these names is that each one occupies a different layer, and understanding that layering is what turns memorization into comprehension. If you keep those 3 questions in mind, you will naturally start placing each technology into the right role. LDAP is best understood as a protocol for accessing a directory of information, and in authentication contexts, it is often the protocol used to look up users and groups. Think of LDAP as the language a client uses to ask a directory server questions like, does this user exist? What groups are they in? And what attributes are attached to their account? A directory is not the same thing as a database table you would design for an application, because it is optimized for read-heavy lookup patterns and for representing hierarchical or structured identity information. In exam language, you can treat LDAP as the directory lookup layer, which makes identity facts available to systems that need them. LDAP can also be used in some environments to authenticate users by verifying credentials against stored values. But that is not its strongest conceptual role for beginners, because secure authentication at scale is usually handled by Kerberos when available. The important point is that LDAP answers identity and group questions, which then feed into Linux's authorization decisions. If a Linux system cannot resolve a username or cannot see group membership, the LDAP lookup layer is a likely suspect. Because LDAP is about querying and retrieving directory entries, its failure modes often look like lookup failures and inconsistent group information. If the directory is unreachable, the system might act as if users do not exist, or it might fall back to cached information depending on the integration layer. If the directory contains incorrect group membership, the user might authenticate successfully but still lack the permissions they expect because Linux is enforcing local rules based on those group facts. Another common failure is name resolution or connectivity issues that prevent the Linux client from reaching the directory server which makes identity integration seem broken even though the directory is healthy. The exam often encodes these scenarios and symptoms like unknown user errors or group membership not showing up on a client even after it was changed centrally. The key beginner insight is that LDAP is about identity facts, and those facts can be delayed or missing when connectivity or caching is involved. When you can interpret a symptom as a missing directory fact rather than a bad password, you are thinking at the right level. Kerberos is best understood as an authentication system designed for secure, repeatable identity proof in networked environments, especially where single sign-on is valued. Instead of sending a password to every service you want to use, Kerberos uses a trusted third party, often called a key distribution center, KDC, to issue tickets. A ticket is a cryptographic token that proves the user has authenticated and is allowed to request a service, and it can be presented to services without retyping the password each time. For beginners, the most important idea is that Kerberos is about authentication proof, not about storing user data like a directory does. It still relies on a shared understanding of identities and keys, and it often works alongside a directory that stores user and service information. But its core role is to allow secure authentication without repeated password exchange over the network. In exam language, Kerberos is the technology you associate with tickets, time sensitivity, and single sign-on behavior. If you see a scenario where authentication depends on a ticket system and fails when time is wrong, you are in Kerberos territory conceptually. Kerberos also has distinctive failure patterns that are worth recognizing because they often look unrelated to beginners. Because tickets are time-sensitive, accurate time is essential, and if a Linux system's clock drifts too far from the KDC, authentication can fail even when the username and password are correct. That is one reason NTP matters so much in enterprise environments. Kerberos also depends on being able to reach the KDC, so network reachability and name resolution problems can appear as authentication failures. Another common pattern is that a user might have valid directory information, meaning their account and groups are visible through LDAP, but authentication still fails because Kerberos cannot issue or validate tickets. This can confuse beginners because they see the user exists and assume login should work. The layered model resolves that confusion. Identity lookup and authentication proof are separate steps. For exam reasoning, if the user is recognized but ticket-based authentication fails, suspect Kerberos and its dependencies like time and reachability. Samba is best understood as a suite of tools and services that allows Linux systems to interoperate with Windows-style networking, file sharing, and domain concepts. Samba is not just a file server, and it can also participate in domain membership scenarios, helping Linux interact with domain controllers and enabling Windows clients to access resources hosted on Linux. In identity integration conversations, Samba often appears because it provides mechanisms for Linux to understand and use Windows domain identities and group memberships in a way that aligns with Windows expectations. This is where you might hear about domain joining, domain authentication, and identity mapping, because Samba can help translate between Windows-style identity representations and Unix-style identifiers used by Linux for permissions. In exam language, you can think of Samba as the compatibility and integration layer that bridges Linux with Windows-centric directory and file sharing environments. It can be part of an authentication story, but it is rarely the only component, and it often works alongside directory lookup and ticket-based authentication. When you see questions about Linux participating in a Windows domain or providing network shares to Windows clients, Samba is the conceptual anchor. Samba's failure modes often appear as interoperability problems rather than simple credential failures. For example, access might work from Linux but not from Windows, or group memberships might not map correctly, causing permissions to behave unexpectedly on shared resources. Another common issue is name resolution and domain discovery, because domain environments rely on finding the right controllers and services, and if that discovery fails, the integration can look broken. Samba-related integration can also be sensitive to configuration mismatches between the Linux system and the domain, such as incorrect realm naming or identity mapping conflicts. Beginners may see these problems as random because they involve multiple systems, but the layered model helps you narrow it down. If Windows clients cannot access a Linux-hosted resource that should be shared, Samba is likely involved. If the user can authenticate but the file access permissions look wrong, identity mapping and group translation become the suspects. For the exam, recognizing Samba as a bridge between identity worlds and file sharing expectations is often enough to pick the correct interpretation. Now connect these three technologies into the common real-world pattern, because the exam often describes integrated environments rather than isolated tools. In many setups, LDAP provides the directory data for users and groups. Kerberos provides secure authentication through tickets, and Samba provides Windows interoperability and sometimes domain membership integration. These pieces are complementary because they solve different aspects of the same broader goal, making identity centralized, authentication secure, and access consistent across Linux and Windows systems. A beginner mistake is to treat them as mutually exclusive choices, like you must pick one and ignore the others. In reality, they often appear as a stack, with identity facts coming from the directory, authentication proof coming from the ticket system, and interoperability coming from Samba when Windows environments are involved. The key exam-level skill is to read a scenario and identify which layer is being described. If the scenario focuses on looking up users and groups, you are in LDAP territory. If it focuses on tickets, time drift, or single sign-on, you are in Kerberos territory. If it focuses on domain joining or Windows share interoperability, you are in Samba territory. It is also helpful to connect this to the Linux integration components you learned earlier, because Linux often uses intermediary services to talk to these external systems. A Linux system rarely has every application speak LDAP or Kerberos directly, and instead it uses integration services that centralize that communication and provide caching and consistent interfaces. That is why identity integration discussions often involve components that broker directory lookups and authentication flows. PAM provides the authentication framework many login methods use, and directory-backed authentication can be plugged into that framework. Polkit provides action authorization decisions for certain privileged operations, which can depend on group membership provided by directory lookup. The point is that LDAP, Kerberos, and Samba are not isolated islands, and they feed into Linux's layered access control model. Understanding that they supply identity and authentication signals that other Linux layers use makes their purpose clearer. If you remember that the directory and ticket systems provide the facts, and Linux enforces permissions locally, you will not expect the directory to directly change file permissions by itself. Another exam-level distinction worth making is between authentication success and authorization success in directory-backed environments. A user might authenticate successfully through Kerberos, proving identity and obtaining access tokens, but still be denied access to a file share or a system function because their group membership does not grant the required permission. That group membership might come from LDAP, and it might be cached or outdated, creating confusion when changes are made centrally. Similarly, a user might be visible in the directory through LDAP, meaning the system recognizes their account, but authentication might fail because Kerberos cannot issue tickets due to time or connectivity issues. Samba can add another layer, because even when identity and authentication are correct, a Windows client might still fail due to mapping or share policy mismatches. These layered outcomes are not bugs in concept, and they are the natural consequence of separating identity facts, authentication proof, and resource authorization. The exam often tests whether you recognize that separation, because it is fundamental to how enterprise authentication works. Once you can tell which step is failing, you can explain why the symptom appears. A final conceptual point is that directory-backed authentication changes the system's dependency footprint, which means basic services become part of authentication reliability. DNS and NTP become more critical because discovering directory servers and validating time-sensitive tickets depends on name resolution and time sync. Network reachability becomes critical because authentication is no longer purely local, and a network outage can become a login outage. This does not mean directory-backed auth is bad, and it means it is a system-level feature that depends on other system-level foundations. In exam scenarios, if a directory-backed login suddenly fails across many systems, the root cause may be a supporting service like time sync or name resolution, not the directory itself. Recognizing that authentication depends on infrastructure is part of thinking like a Linux administrator. It also helps you avoid the common beginner trap of blaming the directory immediately. Often the directory is fine, and the path to it is what is broken. To conclude, directory-backed authentication in Linux is best understood as a layered combination of technologies that each answer a different kind of question. Lightweight Directory Access Protocol, LDAP, is the directory lookup layer that provides identity facts like users and groups, and its failures often look like missing or incorrect identity information. Kerberos, Kerberos, is the ticket-based authentication system that provides secure identity proof and single sign-on behavior, and its failures often involve time sync, reachability, or ticket validation problems even when the user exists. Samba is the interoperability suite that helps Linux participate in Windows-style domains and provide compatible services like file sharing, and its failures often look like identity mapping or cross-platform access issues. These components are often used together rather than in isolation, feeding into Linux frameworks like PAM and local authorization layers like file system permissions and Polkit policy. When you can place each one on the map and recognize their characteristic failure patterns, you can interpret exam scenarios with confidence and explain what is happening in clear, logical language.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.